Hello everyone, welcome to my channel. In this video I have two integrals that I would like us to look at. The first one is this integral here that you see, the integral of e to the power x dx all over in brackets 2 plus e to the power x times the natural log of 2 plus e to the power x. So how do we approach this? Well, here is how we approach it. We definitely have to rearrange this integral so that u substitution can be clearly seen as the technique of integration that we need to apply. So here is the approach. So we are saying our first integral, it's the integral of e to the power x dx all over in brackets 2 plus e to the power x times the natural log of 2 plus e to the power x in brackets like that. Here is how we transform this integral. This integral equals, watch how I'm going to change it, 1 all over the natural log of 2 plus e to the power x times e to the power x all over in brackets 2 plus e to the power x times dx. Now, why is this a case and why is this important? Because now we're going to say let u be equal to the natural log of 2 plus e to the power x. Now, differentiating u with respect to x, you'll agree with me that du dx is equal to, how we differentiate the natural log is we reciprocate that one first, 2 plus e to the power x, and then we multiply by the derivative of that one there, times derivative with respect to x of 2 plus e to the power x. Now, if you agree with me, this is going to be 1 all over 2 plus e to the power x multiplied by e to the power x. Remember, derivative of e power x is e power x with respect to x. That is, derivative of 2 is 0 because 2 is a constant. Now I will have to multiply by dx both sides. Remember, this is du dx being equal to that. Now, therefore, du will be equal to 1 all over 2 plus e to the power x in brackets times e to the power x dx. Now watch, this expression here is exactly that part there. That's why I had to transform that integral like that. Taking us to page 2. This is page 1 actually, not page 2. This is page 1, but we're going to page 2 from here. I'll come and fix that. Let's move on to page 2. Taking us to page 2. Now watch what I'm going to do. In that place, I'm going to have du. It will be 1 over u times du, because this expression equals u, as you can see from there. So our integral now becomes a very simple integral after transformation, page 2. Now we are saying the integral we have here, like I said, this integral now becomes 1 over u times du, because that expression, as you can see here, this is du. So we are now saying that integral is equal to the integral of 1 over u du. You should have seen my previous videos. I've done integration of this a couple of times. This is just the natural log of u, and then because the integral is indefinite, we have to say that we have to add a constant there because there are no limits of integration, as you can see. But what is u? We need to move back to our original variable. U is the natural log of 2 plus e to the power x. That's u. So now we are saying, and notice something, this can never be negative. So therefore, I don't need absolute values, signs. So this is a natural log of, if you allow me to use square brackets, natural log of 2 plus e to the power x. And then I'm going to have to say plus c. Remember, this is natural log of u. And what is u? U is also a natural log expression. U equals natural log of 2 plus e power x. So we have to have it that way. Natural log of 2 plus e power x, and then plus a constant c. So this is the solution to our first integral. Let me just remind you, our first integral is this one here. Our first integral is this one here. Looking very intimidating, but after rearranging it, you can see that it's a very simple integral actually, because it's simple direct u substitution. All right, let's move to integral number 2. Remember, this is page 1. Page 1. Right. Let's move to integral number 2. Our second integral in this video is this one. Here is our second integral. Here it is. We are to evaluate this integral here, or integrate x to the power 5 all over square root of 1 plus x power 3 dx. How do we approach this? If you differentiate this expression under the squared sign, you're going to get 3x squared, and we have x cubed in the numerator. And therefore, we need to transform it as well. So integral number 2, it's the integral of x power 5 all over the square root of 1 plus x cubed dx. Watch how I'm going to transform it. This is equal to the integral of x power 3 all over square root of 1 plus x power 2, power 3 actually, times x power 2 dx. Now notice x power 2 times x power 3 is actually x power 5, because bases are the same, you add the powers. But the reason why I've done this is because derivative of this expression under the squared sign is actually 3x squared. At least we have x squared there. Now it's 3x squared, as you can see, so therefore I need 3x squared there. So I can actually say, all right, I'm gonna divide by 3 and then multiply by 3 as follows: 1 plus x cubed, and then I'm going to say times 3x squared dx. I can do it that way. Now, at this stage, I'm going to now let u squared, because we have square root here, u squared be equal to 1 plus x cubed. Now, we need to obtain an equation from here. The first one is going to be differentiating both sides, or if you like, differentiating u implicitly because it's u squared here. You agree with me? It's going to be 2u du. On the right hand side, we have a derivative of 1 is 0 of x cubed is going to be 3x squared dx. See this expression? Is that expression there? So in that place, I can have 2u du in that place. And over here, I'm going to have u squared under there. But if you look at this here in the numerator, I have x cubed. So I need to solve for x cubed here. So the first equation is that one. The second one is going to be u squared minus 1 equals x cubed. Right. The third one, which we're going to need in the final step, is going to be take the positive square root on both sides. So we're saying square root of u squared, the positive square root is going to be u, is equal to, on the right hand side, we have the positive square root of 1 plus x cubed. So this is going to be square root of 1 plus x cubed. And you agree with me that you can rewrite this as 1 plus x cubed to the power half. That's basically square. We're going to need that expression. Right. So now let's transform this integral then, taking us to, this is page 3, I think. There's about 2 pages. Yeah, this is page 3. Taking us to page 4. What we have now is the following. Just remind you, this integral now will be transformed as follows. We're going to have 1 over 3. In the numerator, I'm going to have u squared minus 1. In the denominator, I'm going to have square root of u squared. And over here, I'm going to have 2u du. There it is, 2u du, representing that. So we are saying that that integral is equal to the integral, of course, 1 over 3 outside there, the integral of u squared minus 1. That expression taking the place of x cubed, u squared minus 1, all over, allow me to put this in brackets, square root of, instead of 1 plus x cubed, I'm going to have u squared, times, instead of having 3x squared dx, I'm going to have 2u du. 2u du. Fantastic. The whole integral is transformed. Now we can go ahead and perform the integration. First, 2 is a constant. I'm going to take it out. So I'm going to have 2 over 3 outside there. Integral of u squared minus 1. U squared minus 1. In the denominator, I have Positive square root there, it's u times, remember we took 2 out and we only have u left there and du, and obviously you can see the u's cancel. So what I have is 2 over 3, and I have the integral of u squared minus 1 du. Now I'm going to distribute the integral and du and keep the 2/3 outside. So 2 over 3, and I'm going to do this. The integral of u squared du minus 1 du, like so. Evaluating these two integrals, I'm going to have 2 over 3 times this. Remember, power rule, add 1 and divide the exact. So u power 2 plus 1 all over 2 plus 1. And then this is going to be minus. The integral of u, integral of 1 du is actually just u. Let me explain something here. Notice something here. We're using power rule. We're basically saying this here integral of 1. The integral of 1 du is the same as integral of u power 0 du. And what do we do? Power rule, you're going to add 1. So this is going to be u power 0 plus 1 all over 0 plus 1. And what does this simplify to? It simplifies to u power 1 over 1, which is just u. That's how we get this u here from the integral of 1 du. Fantastic. Now we're going to say close brackets, and then we have to say plus c. Now let's simplify this and clean up a little bit. 2 over 3, and what do we have here? We have u cubed over 3 minus u, and then plus c. Let me remove the brackets, distribute the 2/3. You'll agree with me, we have 2 over 3. It's actually 2 over 9, because we have to multiply 3 and 3. U cubed minus 2 over 3 u plus c. Now, this is what we have. So we have to now simplify this expression, these two. How do we simplify them? Go back to our original variable. Remember, I told you we're going to need u. And what is u? It's 1 plus x cubed to the power half. So where there's u, I must put this. So this integral changes, therefore. The final solution changes as follows. We are going now to have the following. This will be sufficient space here. And this is supposed to be page 5 now. Page 5. So basically we are saying that what we have now is that is exactly equal to 2 over 9. And remember what I told you, we have 1 plus x cubed power half. But this has to be raised to the power what? 3 minus 2 over 3. And what do we have here? We can keep this as 1 plus x cubed, and we take square root of that plus c. Because u here is just u power 1, so we can leave it this way. But let's simplify this part. So this part simplifies to 2 over 9, and then we have 1 plus x cubed to the power half times 3 is 3 over 2, and then we have 2 over 3 times square root of 1 plus x cubed plus c. You can actually write this as 1 plus x to the power half as well, but I prefer to present it this way. So this is the final solution to our second integral. Just to remind you, integral number 2. This is integral number 2 that we've worked on. I'm going to stop here in this video. I only prepared 2 integrals for you. Tell me what you think about these 2 integrals. Were they straightforward? Your feedback is greatly valued. All right, I'll see you in the next one.